In this video, I'll show you how to express a rational function as a sum of partial fractions to integrate. This is question 5. The function that we'll be integrating in this video is shown below, where we have a quadratic in the numerator position and we have 3 factors in the denominator position. The question we have to ask ourselves is, what happens if we have factors in the denominator which repeat? As you can tell, this factor repeats. How do we find the partial fractions representation in this case? To do this, you must include an extra term for each time a factor is repeated. So we'll start off with this factor. We have a over the factor x plus 3 plus b over x minus 1 plus c over x minus 1 squared. If this happened to be x minus 1 to the power of 3, we would add an extra term, d, where we have d over x minus 1 to the power of 3. Now that we've set up our partial fractions, we can go ahead to combine all 3 of these terms. We'll start by combining these two, where we have x minus 1 times a plus x plus 3 times b over these two multiplied. Next, I'll combine the product of these two, this, with that one. Combining these two, we have the two denominators being multiplied to each other, and this denominator multiplied to these two terms in the numerator, and this denominator multiplied to the c, giving us, if you have combined the two fractions correctly, you should end up with something that looks like this. However, this term needs to be multiplied to this term. We have to expand this part of the expression. Having multiplied this term into this binomial, I get the following expression plus this part. You'll notice that this term, and this term all share an x minus 1. In addition, in the denominator position, we have 3 x minus 1s. This means we can cancel one out here, cancel one out here, and cancel this one. Just think of it this way. Imagine if we factored out x minus 1, since all 3 of these terms have at least one x minus 1 in common, then you can cancel it out with the denominator. This leads us to the following equation. Notice that the left side and the right side both have the same denominator. We can cancel those out and only focus on the numerator, and if you do that, you should end up with the following. This equation here represents only the numerators of the left and the right side. The method that I'll use to find a, b, and c is I'll set certain x values that will make terms go to 0. So if I set x is equal to positive 1, it will make this term go to 0, it will make this term go to 0, and we are left with only cx plus 3. Here's what I mean. 3 times 1 is 3 minus 8 plus 13 is equal to 1 plus 3 is 4, 4c. This side is equal to 8. And this side stays the way it is, therefore c is equal to 2. Let's use the same technique. This time I'll set x equal to negative 3. This goes to 0, this goes to 0, and we're left with 3 times 3 to the power of 2, that's 27, minus, or in our case, positive 24 plus 13 is equal to a bracket negative 3 minus 1, that's negative 4 to the power of 2, is positive 16, 16a. Adding these up, we get 64, 16a, therefore a is equal to 4. And lastly, I'll set x equal to 0. Given that we know what a and c are, if we set x equal to 0, here's what happens. This part goes to nothing. This part also goes to nothing. We have 13 is equal to, we know what our a is, a times 0 minus 1 squared. We know what our c is. This part becomes plus b, 0 minus 1 is negative 1, times positive 3 is negative 3, plus 2 times 3 Therefore, solving for b is equal to -1. So we have our a, c, and b. We can now substitute these into here. Let's go ahead and do that. Now all I have to do is integrate the following function. So once again, here's my integral, and don't forget the brackets around x minus 1. This one is easy to integrate. This becomes 4 ln absolute of x plus 3. This also takes the same fate where we have negative ln x minus 1, the absolute. And here we can treat this like the following, where we have 2 times x minus 1 to the power of -2 dx. Pull the 2 out, increase this by 1, make it over -1, giving us 2 or -2 x minus 1 to the power of -1 plus c, or -2 over x minus 1 plus c. I'm going to take this now and place it right there. -2 over x minus 1 plus c. Now remember, our integral was between 2 and 3. So now we have to evaluate this between 2 and 3. Here's how you would do that. We will subtract our upper limit from the total of our lower limit, 2. Using our calculator, 4 ln 3 plus 3 minus ln 3 minus 1 minus 2 over 3 minus 1. And just to prevent any sort of miscalculation, I'll put this in brackets as well, leaving us with 5.73 minus, now all I have to do is switch my 3's with 2's, giving us 4.43, subtracting this with that, 5.473, and I end up with 1.035. 1.035. This right here represents the area for the following integral between 2 and 3. And there you have it. That is how to express a rational function as a sum of partial fractions to integrate.